in these Chapter 6 videos, we'll be talking about the normal distribution. Remember to pause often, have your spreadsheet technology ready to go, and take notes along with me. These are the topics we'll be covering in these videos. A normal distribution is bell-shaped here. So this is the traditional bell-shaped curve. And the mean, the median, and the mode are all the same. And the mean is right in the middle. We use mu for the mean. And that is the central location in there. So when we talk about these probabilities, it's also important to remember that it cuts it directly in half, which means the probability for the left half is 0.5 and the probability for the right half is 0.5, because remember that the total probability is always 1. So when we talk about the empirical rule here, we're talking about the difference in the standard deviation. So over here, we kind of count one standard deviation away from, so this would be mu plus 1 standard deviation, mu plus 2 standard deviations, mu plus 3 standard deviations. And we can kind of say a couple things about it. So 68% fall within the first standard deviation. So this area here is 68%. And then 95%, about 95%, is in this region here. This is all 95%. And then this whole region is about 100%, right? 1 or 100%. So let's apply the empirical rule first before we learn Excel. So suppose the age of employees in an industry is normally distributed with a mean of 42 and a standard deviation of 5 years. So let's draw that. We're going to be drawing a lot of curves here. So we know that the mean is right in the middle, and our mean is 42, and our standard deviation is 5. So one standard deviation this way would be plus 5, plus 5, plus 5, and then this way would be minus 5, minus 5, minus 5. What proportion of employees are older than 52? So let's see here. Older than 52 would be this section right here. So now we've got to do kind of some math here. So that's 2 standard deviations away. I'm going to change this color. So 2 standard deviations, if we recall from the empirical rule, is that this is all 95%, which means that these 2 tails left over, the whole thing is 100. So that means we've got 5% left over. So this is 5% divided by 2, and this is 5% divided by 2. So the percentage here would be about 2.5%. So now, okay, let's clear this out. What proportion of employees are younger than 37? So we want to know all of this region. So again, that's 1 standard deviation away from the mean. So on both sides here, we know that according to the empirical rule that this is 68%. So what's left over? Well, we know that the whole thing is 100. So 100 minus 68 gives us a whole of 32% left over. So this side is 32% divided by 2, and this side is 32% divided by 2. So 32 divided by 2 means that this side here is 16%. All right, so now we want to know about between. So let's take a peek here. So between 32 and 47 here. So this is what we're after, this section right here. So we know that the whole thing is 100. So we want to kind of take away all these pieces. So how much is left in this tail here? Well, we know that this section here is 68%, right, between 1 standard deviation. So the leftover pieces are 32, and so that this tail here is 16%. So we know it's 100% minus 16%. And then what about this tail here? So if we were to go, I'll just kind of go over here, this whole section here, 2 standard deviations, is 95%. And we know that each of these tails are 2.5%. So this is 2.5%. So now if we subtract all of those, we'll get about 81.5%. So go ahead and give this one a try and press play when you're ready to see the solution. So now let's talk about the standard normal distribution, and we use z for that. And in this particular case, mu is equal to 0, and our standard deviation is equal to 1. This is a special case. Now, you may have seen these standard normal tables before, and we're going to be using Excel instead of the tables. So when we are using Excel, it's always the area to the left. Same thing with the tables here. So we're always talking about the area to the left. So when we talk about the area to the left, we will use these formulas here. So if we want to find the area to the right, we would do, remember the whole thing is 1 minus the area to the left. So let's do an example. So find the following probabilities based on the standard normal variable. So we're going to draw a bell curve for each one before we actually type it in. So for A, we want to know the area, the probability between these two values. So when we're trying to find between two values, we want the probability of the area of the bigger one minus the probability, whoops, sorry about that. We want the area of this to the left of this, but then we want to take away the area of that little tail there. So the way we're going to do that here is we're going to do the normal distribution. Our x value, we're going to do the bigger one first, negative 0.23. The mean in a standard normal for z is 0. The standard deviation is 1, and we'll always end with 1. And then we're going to subtract the smaller value. So that would be negative 0.67, 0, 1, 1. So the probability there, this answer, would be 0.1576. So let's look at B. B has between two values here, 0, which we know is the mean, and 1.96. Now, we can do this a couple different ways, but we basically want to know, okay, this area, take away this area. Now, you might remember that that cuts it in half, so we know that that's 0.5. But you can either know that or not know that. It's not a big deal, but we're going to do the same thing. And I'm actually going to just kind of cheat here. My first z is now 1.96, and I'm going to subtract it from 0. And I end up getting 0.475. And the reason why I could do that was because they were both betweens, so that was an easy one. So now C, we've got another one here. We're doing the curve. This one is negative 1.28 to 0. And again, we're taking the bigger one. We know that one is 0.5, but maybe you don't want to know it. That's not a big deal. You can just kind of type it in here. So that would be the bigger one is 0, and we're going to go negative 1.28. And we would get 0.3997, which kind of bumps that up. We could leave it as 0.3997, or we'd do 4 digits. Now for greater than 4.2, excuse me, 4.2. So we want this area taken away. We really want this area. So remember that it always gives us the area to the left. So because we're looking to the right, it would be 1 minus 4.2. The mean is always 0, 1, 1. And E means that's how many decimal places you move it. So it's essentially 0.0000. And just to show you guys, if we were to add one, if we wanted z is less than 2.2, that's a real easy one because it's already to the left, so we would just type it in. Norm.dis 2.2, 0, 1, 1, whoop, and we would get 0.9861. So go ahead and give these ones a try. Press play when you're ready to see the solution. And we'll pause there, and next we will do the reverse when we're given the probability and we want to find the z-score.